Now you 12, welcome back to the second video in our MM4 topic, applications of area and volume. In our first video we looked at absolute and percentage error, and in this video we're going to look at parts of a circle. Okay, so that's going to be a circle, which I'm sure you're familiar with, semicircle, equally so a sector, which is half of a semicircle, a quarter of a circle, and a sector as well, which is this part of a circle that is bound by two radii here. See, two radiuses, two radii, and an arc here between them. Yep, and I want to work out the area of that shape there. Okay, we might also have a look here, an annulus, right? This is the area between two circles with the same center, right? Different radius. Okay, that's an annulus. New word. How exciting. Now, first of all, area of a sector. Theta, that's this angle in the middle here, right? Theta here. Theta divided by 360, right? So that's going to give me the fraction of the full circle times pi r squared, the area of a circle. Okay, so we just want to find this fraction of the full circle. So in this case here, my area is going to be 80 over 360 times pi times 5 squared. Okay, now trusty calculator here. This is my trusty calculator. Here we go. And I want to type this in. I'm not going to use fraction. I'm going to go, what's this? 80 divided by 360 equals. All right, so there's that first bit. That's my fraction. Now I'm going to multiply that by pi. Use second function button on this calculator to get pi equals. Got that. Now I'm going to multiply it by 5 squared. You might decide to just multiply by 25, but anyway, by 5 squared, and there is my answer. Three significant figures, 17.5. 17.5 square centimeters. Yep, that's three significant figures. Wonderful. Okay, moving on to example, to our next one, the area of an annulus. Now, we could just find the area of the big circle minus the area of the small circle. That's perfectly fine. This is just a factorized form of that. Okay, it would be pi r squared minus pi times a small r squared. Yeah. But nonetheless, we get this formula here. We square the big radius. We square the small radius and take that away from the first one and multiply it by pi. Thing to watch out for, don't subtract the radii first and then square it. Square and then subtract, not subtract then square. Righto? So, here we go. The area of this annulus to one decimal place. My area equals pi times, now the big radius is 5.7 squared, minus the small radius 3.2 squared. Okay, there we go. Notice I didn't write out the formula like this. You don't get any marks for doing that. You will get a mark for doing this much. You won't get any mark for writing that part down typically when this is marked. So, jump straight to there, I think. That's reasonable enough. Next up, we're going to punch this into our calculator. Right, I think we need more practice on the calculator, so I'm going to spend a little bit of time in our videos doing these. So 5.7 squared equals minus 3.2 squared equals, multiply that by pi equals 69.9. Wanted one decimal place. That's pretty easy to round off. Equals 69.9 square centimeters. There we go. Marvelous. Now, there are more parts of a circle here. Area of a semicircle. Yeah, semicircle, half of a complete circle, right? It's half of the area of a circle. This is not rocket science, right? There's my circle. It has a diameter of 30 centimeters. Now, the one thing you get wrong here, you might forget to convert that 30 centimeters diameter to a radius. That means my radius is 15 centimeters. Right? It says draw a diagram, here's your diagram. If you put that 15 in there, that possibly scores you a mark straight away. Now my area equals half times, right, it's half a circle, times pi times my radius, that's 15 squared. Trusty calculator. Okay, all clear. Now I prefer to do this in different order. In fact, 15 squared, I'd do that first. Equals, multiply that by pi. It doesn't take time to press the equals button, and reassures me a bit about my order of operations. Now I could multiply it by half. I could use the fraction. That would all be a whole lot of hassle. Multiplying by half is like dividing by 2. Okay, so there we go. My area equals, it doesn't ask for any number of significant figures. I'm going to go 300, you know what, I forgot to remember that, 353. 353 square centimetres, 3 significant figures. Okay, 3 significant figures is a pretty good fallback. It doesn't say, so just tell them what, tell whoever's reading this, you know, you're writing things down for people to read. Tell them how much you've rounded off. Area of a quadrant, quarter of a circle, right? Instead of the half here, we're going to put a quarter in. Now, draw a diagram, always a good idea. And my general advice is that your diagram should be approximately the size of the palm of your hand. Maybe a little smaller, but not a lot smaller. It should be no smaller than half the size of your phone. You like that? Half the size of your phone is about the smallest your diagram should ever be. Now, radius is 2.5 meters. Yep, so my area is a quarter times pi times 2.5 squared. Trusty calculator. Okay, so again, I'm going to do the 2.5 squared bit first. 2.5 squared equals times pi equals divided by 4 equals 4.9. Doesn't say how much to round that off. I could say 4.91, 3 significant figures. How's that? Let's say that. 4.91 square meters, 3 significant figures. I think you're very unlikely to be marked down for not putting the units in. And if you were to be silly and accidentally put centimeters there instead of meters, as long as there's no unit conversions in the question, I think you'd be unlucky to be marked down. But nonetheless, try to get it right. Try to use the correct units. They're square meters in this case because they had meters here. Try to get that right. Tell them how much you've rounded off if you don't know. That's the end of this exercise here. So this is parts of a circle. We have looked at circles, pi r squared, semicircles, half pi r squared, quadrants, quarter pi r squared, sectors, theta over 360 times pi r squared, and an annulus, which is pi outside of the big radius squared minus the small radius squared. Okay, wonderful. See you in class.